All right, so for this activity, it's called How High and Low Can It Be? So once again, we're looking at a picture. We have a woman down here with a basketball hoop next to her, and we're trying to make reasonable estimates for the maximum and minimum heights of the basketball hoop. So it says complete the first blank in each sentence with an estimate of the height in feet, and the second blank with taller or shorter. So I estimate the minimum height of the basketball hoop to be, so once again, this woman, let's say she's 5 feet tall. She might even be shorter than that. Let's say she's 4 feet tall. Say she's super short because she's about the same height as that ladder, which looks pretty small. So let's say this is twice as tall as her roughly. So I estimate the minimum height to be 8 feet. So this means the hoop cannot be less than 8 feet, right? If I'm saying that the minimum is 8 feet, that means it is at least 8 feet tall. So let's say we'll use H to represent height of the hoop. H must be greater than 8, okay? And we can also add that H could also be 8 feet, right? So if we're saying the minimum, we're saying minimum means greater than or equal to. Right? So the minimum amount of money that you need to, let's say, buy a hot dog at a baseball game is $3. $3 will buy you it, so you either need to have 3 or more. Any less is not enough. So now we need to estimate the maximum height of the basketball hoop. So I know that the average basketball hoop, like a regulation basketball hoop, is 10 feet. So this one looks honestly a little bit taller than that, but not too much. So let's say 12 feet max. So this means the hoop cannot be any taller than 12 feet. That's the maximum that it can be. So once again, H means the height of the hoop. So 8 can be 12, or the height can be less than 12. So once again, the reason being because the maximum means less than or equal to that number. So once again, it's like if I can take a maximum of 5 students on a field trip, that means I can take 5 students or less. The maximum amount that I can bring is 5. I cannot go over that. So maximum actually means less than or equal to that number. All right. Now, the next page, we have to write inequalities for each graph. So we're going to use x for our variable in every one of these situations. And so, in this situation, x, is it going to the left or to the right? So if it's going to the left, that means my numbers are getting smaller or less than. So x must be less than 2, okay? X can be any number less than 2. X could be 1, it could be 0, -1, -7, but it cannot be any of these numbers because that is not included on my graph. Okay? So you can either type it as an inequality or write it as a sentence. All right? So now here, Once again, it's going to the left, so the numbers are getting smaller, going deeper into the negative, so x must be less than -5. Here, once again, left, so it's going to the left, so it's less. We can write the little note. Left is less, right? Anytime we go to the left, it's less. So x is less than 7. Now, for the next two, do you guys notice anything different about these number lines compared to the first three? So the first three all had open circles on the numbers that they started on. So that means, like we said, x is less than 7. Can x be 7? No. This does not say less than or equal to. This is just less than 7. So when there's an open circle, it means that it cannot actually be that number. It can be super close to it, but it can't be it. Now we have these closed circles. So for this inequality, we would actually need to write 2. So we can say it's going to the right, so the numbers are getting bigger. So x can be greater than -4, or x can be equal to -4. Because the dot is closed, it is including -4 as a possibility. So it could be -4 or more than that. Okay? So, and then we're going to rewrite that as a sentence a little bit different. X is greater than or equal to -4. Okay. So same thing here, closed dot to the right. So x can be greater than -3, or x could also be -3 because it's a closed dot. So we are including that as a possibility. And once again, so this is greater than because it's going to the right, or equal to -3. Okay, so now looking at these, let's go back to this basketball situation, right? And see if we can make number lines for these situations. So here I said x, or sorry, not x, we were using h as our variable here, my bad. H is greater than 8, or h is equal to 8. So for my minimum value, so let's say I had a number line here, and let's say here is 8. So if the minimum is 8, it could be, we are saying it could be 8 or more. All right? So that's just a really simplified number line. And then here for the maximum, we're saying h is less than 12 or it's equal to 12. So once again, here's 12. It's going to be a closed dot because it could be 12 or it could be something less than it. Okay. And so now for our big ideas, once again, read this over as always. So inequalities tell us when a value is less than or greater than another value. You're seeing the open dot and the closed dot, reinforcing the difference there. So here, the value could be anything less than 3, but it cannot be equal to 3. That's why it's the open dot. 3 is not included, whereas here, it's greater than 16. So this is x is greater than 16, and x is equal to 16. Here, it's x is less than 3, and that's it, because it cannot be 3 because it's open. And now here are your big ideas. So once again, inequalities can be used to tell us of all of the possible values for a variable. So here, x is greater than 6 means x can be any number greater than 6. It could be 7, 8, 9, 10, whatever, but it can not be 6 or below it. And once again, inequalities can also show the minimum or maximum value for a variable.